What is up, gang? Mr. B here, bringing another sweet, wicked, awesome math video. In this video, I'm going to teach you how to graph the inverse of a transformation. So it's often a topic taught within transformations. We've discussed things like inverses of quadratics. So this is just like, an add-on step to graphing transformations. So if you don't really know how to graph a transformation, this video can certainly help. But I do have another video on graphing transformations that if you want to look below, it's probably down there. All right, so you guys know what to do. If this video helps you in any way, like, share, subscribe. And without further ado, let's jump right into the screen. All right, so we've got a graph of f of x given here. And then we've got a transformational form given to us. And we're asked to graph the inverse of this transformational form. So really, graphing the inverse and graphing the transformations are very similar. It's like 95% the same with one extra step for graphing the inverse. That's it. So this is how I do it. This is my way. If you have a better way, like I tell my students, make it your own your own way, and that works great for you. I'm so happy for you. So I do it a little bit differently. I do what I think works best for most people. That's what I try to do when I'm teaching. So if you find this way maybe a little bit longer than, say, what your teacher's doing or what you would like, then you can sort of, maybe make a few shortcuts along the way. But I sort of take a systematic approach to it that I can apply to any situation for graphing the transformation or graphing the inverse of a transformation. So the first thing I normally would do is check for the double brackets. We got to check to make sure that our transformation is rocking a double set of brackets. And what I mean by that is that this 1/2 is separated from the x with a bracket. So that means there's two sets of brackets inside the f. The actual brackets that the f owns and then the brackets in here. After that, it's just a matter of listing out our a, b, h, and k. Remembering, of course, that our transformation form is y equals a f of b x minus h minus 3. So that's our transformational form. I've got a ton of videos on them, so if you need some refresher on, picking out the values and all that stuff, please go back and look, and they'll certainly help. All right, so the next thing is let's list out the values. So where things are, basically just compare them. So I've got a negative here where the a should be, so that means my a is -1. And then my b value is right here. So b is just b, and then that's 1/2. Now the thing you need to remember about your h value is always the opposite. Because of this minus here, in order to get that plus, it must have been a -1 that was subbed into our equation. So what I tell my students, as you probably have watched on my other videos, h is always the opposite of the sign that's in transformational form. So if there's a plus here, it means my h is -1. If there was a minus, it means my h is +1. And then my k is what it is. So in this case, k is -3, and that's exactly what it is. So from that, we can write a mapping rule. So our general form for the mapping rules, xy goes to 1 over b, x plus h, a, y plus k. So if you're doing a course that involves these, you need to remember these. So write it down, remember it, don't forget it. It's really important that you know these two particular things. The only thing that's really tricky about the mapping rule is the b value. So the b value is reciprocated. So 1 over b means you have to take the reciprocal of b. So our b is 1/2. To the mapping rule, we need to reciprocate it. And when we do, that 1/2 becomes 2. All right, that's the easiest way to think about it. b is reciprocated to the mapping rule. So it becomes 2x. My h value is -1, so -1. A is -1, so I'm just going to put the negative there and not the 1. And then y, and then -3 for my k value. So then, once I have that mapping rule done, I need a table to transform. So I've already got this, thing happening here, so I can get my table from that. So this is my old table. So I always give it different names. Old table, f of x, whatever you want to call it, old/f of x. It's what's given to us, whether it's just a table given or it's actually a graph where we pick the points off. So I got -5 and -3. And if I'm going to make a mistake, chances are it's going to be here, because I'm the king of simple mistakes. -2 and -1, and then 1 and, or -1 and 2, and 1 and 2, and then let's see, what's this, 2 and 3. 2 and 3. All right. So remember, we're asked to graph the inverse. But before we find the table for the inverse, let's just do the typical transformation. We'll talk about what the inverse actually means in a second. So let's go ahead and find just the regular f prime, or the image, all right, or the new, whatever you want to call it. Usually in class, I'm a new old guy, but you'll hear that word image, especially if your math teacher is really particular on notation, which I'm, vocabulary. I explain it to my students, but I try to explain it in ways that they'll remember. Certainly image is not a complicated word, so certainly you'll remember that. So I put my mapping rule as my x and y here in my table, and all I'm going to do is each one of these x values goes into the mapping rule, and out comes something special, right? So it's basically like a input-output machine, or whatever you want to call it. You put your change, you put your 20 into the machine at the arcade, out pops the quarter. It's the same idea. So I put the -5 in, so I get 2 times -5 is -10, minus 1 is -11. So that one's slightly off the grid, but we'll deal with it. And then the next point is -2 times 2 is -4, minus 1 is -5. Ideally, guys, that things would be on the grid, but, you know, nobody's nerfic. 2 times -1 is -2, minus 1 is -3. And then 2 times 1 is 2, minus 1 is 1. And then 2 times 2 is 4, minus 1 is 3. So if I'm making a mistake, chances are I've already made it. And if my students were here, they'd have my back. So -3 is 3. Minus 3 is 0. -1 is 1. Minus 3 is -2. And then -2 minus 3 is -5. And then -2 minus 3, -5. And then -3 minus 3 is -6. So that is my my image, my non-inverse transformation function. So this is basically this guy without even considering the inverse. So for an inverse, what you need to remember is that x and y switch spots. That's all an inverse is. That's how it is defined, the switching of x and y. Well, I've got all my x values right here, and I've got all my y values right here. So all I need to do for my inverse is literally just switch those spots. So I'm going to put the y mapping in for the x and the x mapping in for the y, and then all I'll do is just switch these spots. So there's a couple reasons why I do 3 tables, and I'll explain them now when I get this wrote down. So the first, obviously, I could skip that middle table if I wanted to, all right? And, I've done a gazillion of these. Not saying I wouldn't make a mistake, because I am the king of mistakes, but it's something that if you're new to this, it really opens up the possibility of making a mistake. Here's what I mean. So if I'm going with x, we're so used to putting x into the first column of the table using the mapping rule. We're so used to it because the majority of our questions are just typical transformation questions using the mapping rule. But when you have an inverse, if you skip this middle table, your x value is actually going to go into your second column. And you might just say, well, that's not a big deal. It says x there. I'll remember that. And you know what? Maybe you will. But in the heat of the moment in a test, when you got a lot of stress on you, maybe you got not a lot of time left, so you're feeling a little bit of pressure, to work quickly. That's a mistake. That, you sort of go into autopilot and you rely on your instincts when you're in a test or a high-stress situation, that our instinct is the majority of the time it goes into the first mapping rule. So that's what I've seen happen a lot of times when I've taught that without the middle table. And that's sort of what I've learned over time, is that the middle table really reduces a lot of mistakes. All right, so certainly use it if you want. If you don't want to use it, don't use it. Just jump right to it. If you're a student who's confident in their ability, you work quickly, and you don't mind stress, and you don't make simple mistakes like me, then go for it. All the power to you. All right, now, so let's go ahead and graph this thing. I'll move my ugly mug up this way. So we got 0 and negative 11. Now, I haven't done the check, guys. So one of the things I recommend, obviously, is really checking that you've done the mental math on these. I'm going to pick a couple points just to verify that I didn't mess up. So I'll try the negative 5 again just to make sure. 2 times negative 5 minus 1, negative 11. So that one's good. 2 times negative 2, negative 4 minus 1, negative 5. 2 times negative 1 is negative 2, minus 1 is negative 3. So I'm pretty confident I did these right. If you find a mistake, let me know. But regardless of the table being a mistake, the method is correct. And that's the most important thing. So if you make a mistake in the table, you're not going to lose a lot of marks if you're in my class, because the method is the most important thing. I'm not testing your mental math ability. I'm testing your ability to do transformations. So keep that in mind. So negative 11, and that's x. So I almost made a mistake. So I'll shag off point. Negative 11, or no, I had that right. I was looking back at the round table. So that is right. 0, negative 11. Now I got a big mess made there. See what happens when I'm talking? I just go on these tangents and I lose focus, and whole whack of problems can happen from that. All right, so 0, negative 11, put it right there. Negative 2, PC running low. Negative 2, negative 5, right there. Negative, that is not negative 2. See, got distracted by that little warning. Messes up. So guys, I'm human, right? So, nobody's nerfing is what I like to say. Especially not me. Negative 2, negative 5. Negative 5, negative 3. Right there. Negative 5 and 1. So right here. And then 6, negative 6 and 3. So right here. So it looks something like this. 1, 2, 3. So 1, 2. We're missing a point there. Oh yeah, this guy. All the way down here. So 1, 2, 3, 4. So you always want to make sure we got the same number of points. Guys, obviously use a ruler too when you're doing this. This looks absolutely ridiculous. You know what? Maybe I should do it. I should do it with a ruler. Undo. Here we go. Let me try. See if I can get a ruler. Straight line to line. Here we go. So we go here to here. Here to here. Here to here. And here to here. Looks a little bit better, right? And there it is, guys. There's transforming an inverse. So it's really not that complicated in terms of, it's not really that much of a different process from doing a regular transformation, just with one extra step. Switch in those x and y's as your last step. Of course, you could do it somewhere else along the way. I leave it to last. And that makes it very useful. If you're looking for some more information on inverses and things like that, like domain and range and all that kind of stuff, I don't have a video made for that, but I probably will be eventually, but certainly won't be for a couple days. But thank you guys for watching anyway. If you need another video, drop it in the chat and let me know. Thanks for watching, and as always, like, share, subscribe, and I'll see you guys in class. Peace!
A lot of boring math.
Get the fork out of here.